thanks so much for joining me today, everyone. My name is Brandon Minnick, and in today's session, we'll be talking about building your first mobile backend using App Center data. I'm a mobile app developer. I've been making apps for iOS and Android for a few years now, and I like to make my apps in C# using Xamarin. And I actually used to work at Xamarin, which is how I ended up at Microsoft. They acquired us a couple years ago. And when they did acquire us, I was a really good mobile app developer, but I didn't know much about how to create a backend. I didn't know a lot of stuff about cloud and APIs and databases and then all the crazy stuff like security and authentication. And when we joined Microsoft, they definitely encouraged us to learn more and learn like how to do all this stuff in Azure. And so I did. Microsoft offers a lot of training and has a lot of classes available. And after about a year, I finally started feeling comfortable to be able to build that API, to be able to connect it to a database, make sure everything worked together. And then probably about another year after that, I started feeling comfortable with security and authentication and all that fun stuff. And so when I heard about the App Center team a couple of months ago releasing this product called App Center Data, where they claim that you don't really need to know any of that, that you can create your mobile backend in just a couple clicks, it's just a couple lines of code, I was pretty skeptical because I had just spent 2 years figuring all this stuff out. But it turns out it's true, it works. And so I wanted to share that with you today. To show you how easy it is to get started and how powerful this backend is. So before we get going, I want to point out there's a couple links at the bottom of the slides. You'll see on the left, that is my Twitter handle. This is the best way to reach me. So if you have any questions or you want to chat about mobile or Xamarin or Azure stuff, I'm always happy to. Feel free to shoot me a direct message. My direct messages are always open. And on the bottom right, we have a link to a website that I put together just for us today. This is where you can find everything we're going to cover. So I've posted the slides there. We're going to jump into some code in a little bit. And so I have the completed open source samples available for you. So don't worry about memorizing any code today, even though it's really just like a couple lines of code. But yeah, feel free to reference that. I've also have links there if you want to learn more about App Center or Xamarin, and it'll help you get started with your apps. So how does this work? How does this App Center data thing actually create a backend for us? Well, it's running off the power of Cosmos DB. Who here has heard of Cosmos DB? Okay, a couple folks, good. Who here's, keep your hand up if you're using Cosmos DB. All right, not as many folks, that's okay. Well, so if you haven't heard of Cosmos DB, it's a pretty new database technology that Microsoft's created in Azure, and it's what you call a globally distributed database. And so Cosmos does this really cool thing where you can tell it, I want my data to live here in this data center, and then also over here in this data center, maybe across the world, maybe over in Australia. And this is huge. This is huge because data can only move so fast. So when our users open our app, if our data lives here in Prague, but our users open our app in Australia, well, the request has to go from that user's device all the way around the world, here to Prague, pull the data out of the database, and then go all the way back to Australia. And that takes a couple hundred milliseconds. Like I said, data can only move so quickly. And that might not sound like much, a couple hundred milliseconds, but that's only for one request. What if that data, or what if it's a large request and they're requesting a lot of data or a big download, or maybe there's multiple requests, and so that round trip time really starts to add up. But what we can do with Cosmos, we can literally say, I want to replicate all of my data in Australia, and it does it automatically for us. We don't have to know anything about databases. We basically, and I'll show you in a minute, you click a button and it's done. And so now anytime our database is updated, anytime there's reads and writes, they will all get replicated across the world. And the coolest thing is, they use the magic of DNS to make sure that the user is automatically directed to the closest data center. So in our apps, we just have to tell it to go to our URL for our Cosmos DB backend, and Cosmos DB takes care of the rest. It'll automatically make sure they get routed to the closest data center, so you get, instead of a 100 millisecond round trip time, more like a 10 millisecond round trip time. Then on top of that, Cosmos also has this low latency guarantee. And I'm not a database person. I don't know how they do any of this. It's just magic. But they guarantee that every read will only be 10 milliseconds, and every write will only be 10 milliseconds. So if you have your database distributed around the world, then you don't have to worry about long round trip times. And then on top of that, you don't have to worry about long reads and writes. Even if you're pulling out a lot of data, it'll be 10 milliseconds. So pretty cool. Like I said, I'm a mobile developer. I'm not a database expert, so don't quiz me on how they do it, but I'm glad they did. So enough talking about it. Let's jump out of the slides and let's check it out. So the first thing I'm going to do is just going to go to appcenter.ms. This is the App Center website, because I have this app here that I want to hook up to App Center. So the first thing we'll do in App Center is say that we want to add a new app. And let's see, let's call it Update Prague Data. And this will be an iOS app that we made in Xamarin. OK, so we will be pretty much living in this data tab today. But if you haven't heard of App Center before, it actually has a whole bunch of tools that we can use as mobile app developers. There's things like Build, where you can hook that up to your code repository. So if your code lives in GitHub or Bitbucket, you can connect that to App Center Build, and it'll automatically kick off automated builds anytime you commit your code. That way you know you didn't break anything, which is nice. And speaking of breaking anything, there's also tests. So the App Center team has literally thousands of real iOS and Android devices that we can use for automated UI testing. So you write a couple automated UI tests, and then you can run them on all these different devices, and it's great. I use it for my app anytime I'm about to push to the App Store, just, again, make sure I didn't break anything. Distribute, that helps you get your apps to your beta testers, so you don't have to go necessarily through the app stores to do it. And diagnostics will help you get crash reports. So if your app crashes on your user's device, App Center will make sure that that crash report comes back. Analytics shows you how many users you have, where your users are, how they're using your app. Authentication, push notifications, but we'll just jump straight into this data tab for today. So getting started is actually pretty easy. So we just tell it that we want to create a new database. We connect it to our Azure subscription, and then we give it a name. So let's see, how about update demo? And then it'll double check to make sure nobody's used that name before. All right, because the name of your database is actually used in the URL. So our URL is going to be updatedemo.documents.azure.com. So it always has to make sure it's a unique name. And let's put this in Europe. There we go. That's close enough. And now, if you know how much throughput to expect, you can dial that in here and configure your database now. I mean, I don't, but this is also just going to be a sample for today. So I'll just say I'm just getting started, and it'll kind of give me the default lowest throughput rate, which will be way more than enough. And then we just say, create database. And now it's off and running. So we have this notification here saying that it's connecting our database, and that's going to take a few moments. And it does. It takes about 5, 10, 15 minutes. So instead of just kind of hanging out with everyone, waiting for that to finish, I figured let's jump into one that I've already created, this one right here. So once that database has finished configuring, we're greeted with the portal, so it shows me this is the one I created in the US. And down here, it also gives us some stats. So this is where they like to show off that whole latency metric, where they promise 10 millisecond reads, but really it's actually like 1 millisecond. And then for the writes, Yeah, mine typically average 4 to 5 milliseconds, so pretty cool, but the data is really what we care about. So on the Data tab, this shows everything in our database. Now, right away, you'll notice we're not using SQL. We're using NoSQL. How many folks in the audience are using NoSQL? Okay, a couple folks. And then raise your hand if you're familiar with SQL. Okay, cool, yeah. Me too. I've just started getting into NoSQL. So what is the difference, right? What is NoSQL versus SQL? Well, in SQL, everything's structured. It's literally called a structured query language. And that means we have to define everything ahead of time. So we say we need to create a table. And in that table, we're going to have a column for our ID. And that's going to be a number. And then we're going to have another column for a name. And that's going to be a string or a varchar. And we define that all ahead of time. And then any data that comes in to this table has to align to exactly what we created. So it has to have ID as a number, it has to have a string as the name. If it doesn't, SQL doesn't know what to do. And honestly, that's fine. I mean, we live in a structured world in .NET and C#. Everything's very type safe, and I like that. But SQL starts to become a pain when you need to change things or add things. Like if we want to add a new type to our table, well, we have to add a new column. And then all that existing data that was there before, we now have to assign default values to it. Or if we want to change a column, maybe ID, we don't want to be a number anymore, we want that to be a GUID. Well, now that requires a whole database migration, and those are always a pain. And so, there's tools like Entity Framework that are good at helping ease the pain a little bit for us, but those are what NoSQL is attempting to fix. So the way NoSQL works, instead of putting everything in a column, everything here is just JSON. And it looks a little scary, I get it, because there's a lot of weird data right here. But all of this stuff with these crazy numbers and letters, I have no idea what this means. Well, I know this one's a GUID, and I'm pretty sure this one's a timestamp, but don't quiz me on any of these. Like I said, I'm no database expert, but all we have to worry about for our data is this right here. So we have everything in this document JSON object is what we will be using in our app. So let's see if I can show these side by side. So in my app, let's see, that, and there we go. So in my app, I have a class message model that contains a string message and an int number, and that's exactly what we are saving here in our NoSQL database. So really, yeah, this looks scary and weird, but I only really care about this stuff right here. And if you're familiar with JSON, then this is pretty easy to read. Now, the other thing we kind of need to care about is this partition key, because you'll notice some of these say public, and some of them don't. So what this means is, in App Center data, they give us the option to have data in our database that's going to be available to every user. So this one marked public, any user that logs into our app will be able to download this data, actually, even if they're not logged in. This is just open, anybody can access this. And that's why this partition key says read only. If we click on one that doesn't say public, well, this is user-specific data. So this also has an ID. Oh, no, partition key, there we go. This also has a partition key, but you'll notice the partition key says user, and then it includes the user's GUID. So this is from a user who has logged into our app and has submitted data to our backend, but this user will be the only one that's able to read and ingest this data. So we get two types of data. It's all JSON blobs, and again, the advantage of that is if we wanted to add more to our model here, like maybe we wanted to have add a string name, we can do that here in C#, and then the next time we add data to our App Center data backend, then it'll just add it in as another row, or another, yeah, I guess we could call them rows. It'll be another row here in this document blob. So NoSQL is a little bit more flexible, and from what I've heard from database experts is that NoSQL also makes it easier to replicate, and I don't know, they call it sharding. Don't quiz me on what all that stuff means, but all that crazy stuff that they do to automatically replicate our database around the world, NoSQL helps with all that. Now, speaking of replicating around the world, let's jump back to that first dashboard. There we go. So one thing I do want to point out, this is still in preview. This is kind of hot off the presses. The App Center team just announced this a few months ago, and they're still working on adding some features. And one of the features that doesn't exist here in the App Center portal, that we'll just jump over to the Azure portal to show it off real quick, is the ability to select the different data centers. So let's check that out real quick, because this is really cool. So if we jump over to Azure, this will bring us to our Cosmos DB instance in Azure. We'll give that a minute to load. OK, there it is. So if we tap on Replicate Data Globally, let's see if we can zoom in a bit. Perfect. So this is how we can choose which data centers will host our data. And there's a couple things going on here. But let's see, the first one is this multi-region rights. So if we come over here just a little bit, there we go. So you notice the central US is a different color. Do we notice that? Yeah, we can notice that. Then the South Africa, then the Australia databases or data centers that I've checked. And that's because the central US is my master database. So the way I have this set up and the way it's set up by default is you have one master, and then that'll be what replicates to every other database. So even if my user's in Australia, when they open the app, it'll read from this database. But if they want to write or add anything to it, that data comes all the way around the world to the US to be stored here. And then once it is stored here, it gets replicated out back out to Australia, back out to Africa. And we can change that. If we wanted to enable multi-region rights, well, then we can have this multi-master system. So now you also get faster write speeds. But that being said, I'm pretty sure that also comes with a little bit of a cost overhead. So if that's something if you need, great, it's there. But if you don't, then you can save a couple bucks by leaving it off. There's also some cool things like manual failover. Maybe we are about to have a conference in Australia, so we expect a lot of our users to be there. There's going to be heavy usage. So what we could do is we could just essentially move that master to Australia. And literally with just another click, I just say, I understand and it's OK. And then it does it all for us. Automatic failover. This one, I should probably turn this on, but it does exactly what it sounds like. So if something catastrophic happened and the US central data center went down, well, it would just automatically fail over to a different database of your choice. So pretty cool stuff. And getting back to that geo-replication, the way we do that, if we wanted to replicate it to Europe here to get a little bit closer to Prague, well, I just select the data center, and I select Save, and that's it. And now Cosmos is just taking care of the rest. So all my data will be automatically replicated here. We'll have shorter round-trip times. Happy days. Now, it does take a couple minutes, so we'll just leave that running in the background, which will be fine. OK, so let's actually jump into some code. I have an app here. This is a Xamarin app. So everything's written in C# for iOS and Android. And right now, it doesn't do too much. Well, and it's not a very pretty app. We just have a couple buttons. We've got an output label here. And OK, yeah, I haven't wired up any of the buttons. So I'm clicking this. Nothing's happening, which is good, because there's no code there to do anything. So what do we do to get started? Well, the first thing we'll do is we'll come into here, and we'll go into this onStart method. This is the method that's called every time our app starts. And so what we need to do is first initialize App Center. So we'll say appcenter.start. And we pass in our unique ID. So let's grab that. And we'll just copy paste this in. And we'll tell it that we want to use App Center data. So once App Center data has been enabled, then we can start hooking up some code to those buttons. So if I jump back here, this is the code for this page. We basically have a method for each button, right? Like we have a sign-in button up here, and then we have a handle sign-in button clicked, and we have a get shared data button here, and we have a get shared data button clicked. So let's do this one first. Let's see how much code we have to write to connect to this backend. So let's do something like this. Let's say output label.text, and we'll say, just to let the user know that we're getting shared data. And then to get the data, very complicated, we'll say var documents. Oh, and this is another NoSQL term. Let's explain what a document is real quick. So if we jump back to our Data Explorer, give it a second to load, there we go. We'll notice up here, it says we have 19 documents. So just to translate, in SQL, everything's in tables. In NoSQL, everything's in collections. And then in SQL, inside of that table, you have rows. In NoSQL, inside of that collection, you have documents. So what we're doing in code here is just requesting all the documents. So we'll say documents, await data.listAsync, and we'll tell them that we want to pull down our message model. And then the other thing we add in here is we tell it that we want to get the app document. So these are going to be all those public ones. So when we call this code, we should expect to see shared data message 1. I think this is shared data message 2, shared data message 3, so on and so forth. So that's it. That one line of code, and now we've got it. So let's go ahead and just print them to the screen. Just write some quick and dirty code. When you're doing your code, you definitely want to make this a little bit prettier, but we'll keep it easy for the sake of the demo today. And so we'll say for each document in documents, we'll first pull out our message model, and we can do that by saying document.deserialized value. And so this is, just for verbosity's sake, this is our message model. And let's just print to the screen whatever value we get. So we'll say message model, whoops, add that in. We'll say message, and then we'll say number. And that looks pretty good. So let's run this and let's see what happens. Actually, while that's building, I wonder, nope, we're still configuring the new database, so we won't be hitting the one in Europe just yet, but that's okay. All right, app's launching. There we go. So now we have our get shared data button. When I tap this, should be talking to our Cosmos DB database, and there it is. And that's not super easy to read, but let's try this for next time. We'll add in some line returns. So we see shared data message 1, 2, 3, 4, 5. So great. So they're all there. Now, what about, there we go. What about these non-public ones? What's the crazy code we have to write for that? Well, it's basically the same thing. So I can pretty much just copy paste this, which will be nice. But instead of requesting the app documents, here we're just going to request the user documents. So let's run this and see what happens. All right, app launch. Let's make sure share data still works. Oh, that looks great too. All right, so now we'll say get user data. And what happens is our app crashes. And our app crashes because it's mad at us that we're not authenticated. So we just tried to get user data from App Center data, but App Center data has no idea who we are. So it makes a lot of sense that it would throw this unauthenticated error. So what we need to do, we actually need to touch on App Center auth real quick. So I already have this set up, but let me show you just what were the steps to do it. Now, App Center off leverages Azure AD B2C. That's a lot of letters and numbers. It's Azure Active Directory, what's B2C? Business to customer. So if you already have that set up in Azure, all we're doing here in App Center is connecting the accounts together. And oops, let me copy that before I forget. I think I got it. So similar to data, it's just a couple button clicks. If you already have it set up. So we'll go ahead and just connect to our existing login page. And let's see if I was able to, nope, did not get it quick enough. Let's jump into Azure then, because I need to copy and paste that. Whoops, not learn more. Oh, cool. Looks like you're set up. Thank you. And there it is. So we'll tell it to use this user flow. Cool. So similar kind of story for adding this code to our app. We jump back over to where we initialize data, and then we just tell it that we also want auth. And these are all included in NuGet packages, by the way. So ahead of time, I went ahead and just installed, where they are. There they are. So we have App Center auth installed, and we have App Center data installed. And then now, we can actually sign in the user. So let's go ahead and wire this up real quick. So we'll say signing in. And similar to data.list async for getting the data, we can say user equals auth.sign in async. And let's make sure we await that. And so now our user should be signed in. So we'll say, let's just say signed in as user ID. Why not? It'll just be some random GUID and numbers and letters, but let's run this now, because now we can sign in, and then we should be able to get the user-specific data. Okay, so quick sanity check, get shared data, still works. Sign in, cool. So it's asking us, do we want to go to this sign in page? And we say, yep, that's fine. And this is the same sign in page that I already created, and I created my own user account here. So we'll say brandon@microsoft.com, put in my super secret password. Cool, so there we go. So now the user's signed in. And so now when we say get user data, the app shouldn't crash. And there we go. So there's all the user data. So we have a bunch of user data messages, a bunch of numbers. Looks like there's a couple 12s for some reason. But this is looking good. So the only other button we have here is add data. So let's do that. And actually, I just noticed that is shared data. Let's make this bigger so I can read it. That should have said getting user data. And let's make that. There we go. Just cleaning up our code, you know. Okay, so add data. So now, what if the user wants to submit new data? Well, similar story. I think you guys are starting to see a trend here. Let's see. So we'll say adding new data. And when we add it, it'll return the document that was added to the database. So when we say add data.create, message model, and then we'll tell it, let's see, document ID. So this will just be a GUID. And let's just give it a new GUID. And then we'll create that new data. So what did we go up to last time? We went up to, we said user data message, up to 13. So in this case, we'll say user data message, and the number will be 14. All right. Oh, and one more. We have to tell it that this is going to be user specific. So partitions, user, good, everybody's happy. And then we can go ahead and output that. We'll say created new data, and what should we choose? How about it's JSON value? Let's see what that shows. That'll be fun. Okay, so we have add data. Looks like all the code's there. Build it, run it. Let's make sure this works. Okay, so quick sanity check, shared data. Should I do user data without signing in? Okay, cool. So it keeps me signed in. That's great. And then add data. So there we go. It just created that new data. And if we say, well, let's do a couple things. Let's first look at, let's double check. You know, it's the whole trust but verify. So if we go back into our data explorer, our newest document down here, yep, user data message 14, and we'll just trust that this is our timestamp. I can't read that number, but now when we say get user data, we should have a 14 in there. Now, something that's also really cool with all of this, I mean, not only was it easy to set up and get started, I mean, it's just basically one line of code to interact with our database back and forth, but if we do something crazy like turn off the Wi-Fi, what happens if we say add data again? And add it again, and maybe 3 more times. Well, if I get user data, look how many 14s are here now. So even though we're offline, even though we're not connected to the database, the App Center SDK is actually caching everything locally, which is pretty cool. And if we come back in here in our outputs, let's show this off, because we can say, let's see, is cached, and all we have to do is ask the document to say, is this from the device cache? And let's go ahead and bring that over to user data 2. And so let's check this out. So Wi-Fi is still disconnected. I'm not connected to the Ethernet cable either. There we go, got a ping running just for solidarity. So we'll say get user data, and now it says it's all coming from the device cache. So this is huge. This is something that, I mean, as mobile app developers, this is one of the hardest things to implement. I've written my own database syncing technology, and it's like 100 lines of code, and you have to check a bunch of things, and it's a pain. But we kind of just get it for free with App Center data, which is pretty cool. And I love that they did this because it follows that offline first mantra. You know, as mobile app developers, we can never trust the internet connection. We have to always make sure our app works whenever the user's offline, because they're going to use it on a plane, they're going to use it on a train, they're going to use it wherever, and they might not have an internet connection. And if it doesn't work, then you get angry reviews in the App Store. I've literally had that happen. Somebody's like, I wish I could use this on my flight, but it didn't work. 2 stars. I'm like, great. So App Center data, offline first. And now if we reconnect to the Wi-Fi, let's give a second for these pings to come back. Awesome. So now, let's see, how many 14s do we have here? 1, 2, 3, 4, 5, 6. Oh, I clicked that a lot. Let's add 1 more, so let's make it 7. Maybe we just go get the data? No, we're still getting it from the cache. Let's see, sometimes you gotta force the issue. If you relaunch it with the Wi-Fi connected, get user data, there we go. So now this is getting the data from the server, and from the server is coming back all of our 14s. And so as basically, once the device came back online and we relaunched it again, App Center data synced everything back up. And if we look back in here, we should have, let's see, this says 20 before I refresh it. Loading. Loading. Come on, App Center. That's probably just the conference Wi-Fi. How are my pings doing? We're dropping some packets, yeah. Well, there's now more documents in the database. Totally confirm that. All right. So I know I threw a lot of stuff at you, but just as a quick review, App Center data uses Cosmos DB. It's a globally scaled database. Like we saw when we jumped in the Azure portal, you can just essentially do a couple button clicks, and we can have data replicated all around the world. We can choose to fail over data. We can change to multi-master, all this stuff that I have no idea how to do if I was making this database myself. Now I don't have to, so I just click a couple buttons and happy days. I wish this was around a couple years ago. And yes, it's NoSQL, but honestly, you don't even really have to worry about that, because from our code, we can do everything in C#. We never really have to worry about how the data is stored. We can just kind of trust that it is. And that SDK caches data locally. So if the user doesn't have an internet connection or has a poor internet connection, all that data will be saved. They don't have to worry about losing anything. And then once the app has the online connection again, everything gets synced back up. And so if there was more data on the remote server, that would come down too. And it's just this beautiful offline first experience, which I really appreciate, because I know I've spent weeks of my life implementing this myself. All right, so if you haven't had a chance yet, make sure to take out your phone, grab a picture of this link, because this is where you can find everything from today. I've included that the same code sample is completed and available on GitHub if you want to go check it out. I know it's just a couple lines of code, so it's not too hard to remember. But I've also included the slides and a bunch of links if you're interested in learning more about App Center data, or I know we didn't jump too deep into App Center auth, but I included some links to that and some more fun Xamarin stuff. If you're wondering how I was able to make that app for iOS and Android using C#, that's all done in Xamarin, and I included some links to that as well. Thank you. Okay, great. Looks like we have some time for questions. What questions do you have? Sure. Oh, yeah, that's right. Microphone. Come on in.
Okay, hi. I have no idea about NoSQL either, but what didn't make sense to me is how was the storage tied to the collection? Like, I have never seen nowhere in the code. Like, you specified the model of the document, but you didn't specify which collection. Is it because there's some default, or?
So it looks like it's putting it all in the same collection. If we jump back over to look at that portal, well, if it loaded, maybe refresh. Are we dropping packets? No, it looks good now. Oh, there it is. So yeah, this is all the same collection. And again, I'm not a database expert. I mean, so to answer your question, yeah, it's all just going in the same collection. So like this is the user data. Like this was the user data that we just created with number 14. You know, if we wanted to, we could create, whoops, not edit, I want to add. So like if we wanted to add one, we could add in some data here, and we'll say like, we just created this 200, and you hit save, you get all that crazy metadata, and if we say get shared data, we just created this 200. So everything's living in that same collection. Now, I'm definitely not a NoSQL expert, but I have talked to the Cosmos team, and they actually recommend, if you can, to put everything in the same collection. Well, caveat, they recommend that because it's the cheapest option. Now, did you say you are a NoSQL expert?
No.
Oh, okay, cool. Well, me neither. But I was going to ask, I'm not sure what the pros and cons of having different collections are, but yeah, the Cosmos team says that if you want to keep the cost low, you can put everything in the same collection and there's no performance impacts or anything like that.
So if I were to store different kinds of data, does it differentiate by if it can deserialize the JSON or not? Or
So yeah, this one's kind of weird. I'm not sure what the team will do. So I'll show you, let's say.
Or it's probably in the metadata somewhere.
So I've done this stuff manually with NoSQL, but just to give you an example of like what is App Center doing if we have a, let's say, a new model, and this will have a, let me say, like public string. I don't want to do ID because that's already one of the metadatas. How about name and public int age. So the way it works right now, oh, it's just yelling because of C#8. So if we wanted to add in a new model, I just realized I did that, huh? We'll say Brandon and age 100. Oh, and we have to tell it that's a new model. And all right, let's do this. So we'll, no, because this will be a user model. There we go, code on the fly. All right, so we'll go ahead and put a breakpoint here. So I'll show you what I learned, but I'm not sure. Oh, whoops, because we said, look at us in type safety. Thanks, C#. Oh, of course, all this stuff. Name, age. All right, now it'll build. So what I saw is it'll pull everything back, but the deserialized value will just be there. Let's see, let's first add it, and then get user data. So we'll just look at this in real time. All right, so let's zoom in. So we have 21 items. Maybe it's the bottom one, hopefully. Okay, so there's our JSON value, and we obviously don't have 21 new models, so there's the JSON value for the other type. And then, let's see, so the deserialized value here, what it tries to do is deserialize this, what is our message model into a new model, and that obviously fails. That's why we have 0 and null. And then it deserializes new model into a new model, which is why that works, and we can see my name and my age. I'm just a lot younger than I look. And so right now, yeah, the SDK is pulling everything back. So this is something that I'm interested to talk to the App Center data team about. If they, because like you said, not all of those deserialize. So if I'm not asking for message model, maybe don't give me message model. And so, yeah, it is still in preview, which is why it's really cool to play around with this, know that it exists, but I kind of hope that that's one of the, I don't think it would be an API change, but feature changes that they fix in the app. But I mean, for now, what I would just do here is just say, I could add in a little select statement to say, documents dot where, there we go. And we'd say something like deserialized value dot name doesn't equal null. And then, that would fix it in my code, but yeah, why not try and like go the extra mile and help the user out with the SDK, but also, what if you could only return back the data that the user's asking for? And then, if that collection had 1 million documents in it, but you only wanted 2 of them, it'd be kind of silly to pull them all down. But yeah, good question. Thank you.
Maybe another question. Did you
Sure.
did I understand right that you created the login page yourself, or was that some kind of template? Or?
Yeah, so the login stuff, that is, let's see if I can use this shortcut. So to answer, the short answer is yes, I created that all myself. Right now, so auth is also still in preview. And so a lot of what you have to do now in the Azure portal will be coming in, more of those features and that workflow will be coming in here. But yeah, so what I did, I created this application. And then, I don't know how familiar you are with authentication stuff, but essentially define, like, these are the redirect URIs for the application so that when the user's done signing in, it'll automatically relaunch my app, and then you can define your scopes and all this stuff that if you've ever played around with OAuth before will feel familiar. If you haven't, then this all feels very alien, which it definitely did my first time. And then you can also, what's pretty cool is you can have multiple identity providers. So like, I was lazy and I only did this one for email. But if you want to let the user log in with their GitHub login or with their Facebook login, you essentially just create those OAuth apps in Facebook or that OAuth app in GitHub, and you can connect them up here. And then on that login page, instead of having username, password, you would have like a GitHub button or a Facebook button so they can log into. And then the last thing you do, you just have this flow. So what do you want it to look like when the user logs in? And this is where, if you were feeling fancy, you could actually customize that login page. You could add like your own, your company's logo to it. This is also where you can say, what values do we want the user to enter in? So do we want to know like their name and their country? Like what do we need for them to authenticate and all that fun stuff? So the experience isn't in App Center just yet, and OAuth in itself is kind of like it's kind of a beast. There's a lot of terminology in there. If you've never used it before, that can be a little confusing. But like I said, it's all in preview, so a lot of that will be coming into the App Center portal. And what I'm hoping is the same way we were able to just create a new database just by clicking a couple buttons in the App Center portal, that they'll make that similar easy say user experience for App Center Auth. But yeah, that was all created ahead of time.
Yeah, I was wondering because the page was just horribly not responsive and looked terrible on the phone. So if you want to use that for a mobile app, that's kind of awkward.
Yeah. So yeah, like I said earlier, like you can change.
You could customize the layout.
Yeah, if I want to look pretty, I could change it. You can even use like, we zoom in a little bit. Whoop. So you can use like custom URLs and stuff, and you can make it look pretty. I did. Good question though. Thanks. What other questions do you have? Looks like all the way in the back.
Is it possible to authenticate not via some page, but let's say you have some form in your application with login password fields, and you call some, let's say, API where you send these credentials?
We'll say yes and no. So because App Center just uses Azure AD B2C, it's already possible in App Center AD. They haven't implemented that yet in the App Center Auth SDK. I'm not sure if they plan on it because it's actually not recommended to do that. The best way for users to log in from mobile is, and I know it's annoying, but to use that standard OAuth flow and have that page pop up. And the reason behind that is when I logged in there, well, we'll say when the user logged in there, I, as the developer, had no way of pulling out their credentials. So what happens when we have the form baked into our application where the user is just entering into the text boxes? Well, the developers can access all that information. You know, I can save that password, I can send it to China, I can do whatever with it. So it's not recommended, but yeah, it's totally possible in Azure AD B2C. But yeah, to answer your question, I'm not sure if it is possible or if it will be possible in App Center Auth. But yeah, I know it's one of those things. It's a better experience for the user, but it's one of those things like kind of how now we have HTTPS and the little browser had a little lock icon in the URL. The users kind of need to come up to speed on that security. So like in the browser, if the user navigates to an HTTP page, the browser is going to yell at them and say, this is not secure, like don't trust it. Users of mobile apps kind of need to get there as well to be like, oh, I'm entering my credentials right into the app. I don't trust that. So we'll see. I don't know if that'll ever change, but that's always the debate with logins is, do we go with the better user experience where we have our hand-created page, you don't have to have the web browser pop up, or do we follow best security practices and kind of force them to do it that way. So, good question. I don't know. All right. Well, thanks so much, everybody. I'll be around for the rest of the day if anybody has any more questions, and thanks for coming.